Hello students, now today we will discuss basic electrical engineering. In first module we will cover DC networks. In DC networks we will go through the modules Ohm's law, then generalization of Ohm's law, that is Kirchhoff's law, then reduction theorem, network theorems, there is your Thevenin's theorems and Norton's theorem. Thevenin's theorem and Norton's theorem. Then another theorem is maximum power transfer theorem and superposition theorem. Superposition theorem maximum power transfer theorem. These modules naming as DC networks. First of all, what is DC and what is AC? Already you have studied in plus 2 or 11th and 12th electrostatic chapters. What is the basic difference between AC and DC? The basic difference, what is the basic difference of alternating current and the direct current? Direct current means what? Direct current means it is a unidirectional current. That means unidirectional current, the charge can flow through in one direction, that is called the direct current, or current can flow through a uniform direction is called the direct current. But in case of alternating current, like is your the current can flow through one direction certain period, then it will flow through another direction the next half cycle. So in AC this is your alternating current and this is your direct current. The current or charge can flow through one direction. Here the charge or current or can flow through one direction, again another period it will go, the direction will change. The major difference between AC and DC, in AC have some frequency, but DC there is no frequency. In DC there is no frequency, frequency is 0. In DC frequency is 0, there is no frequency, but here in AC there is some frequency. In standard frequency let 50 or 60 Hz like this, so there is some frequency. What is another can you say another difference between AC and DC? In AC it is a you can travel the current transformation can through a long distance safely in AC, but in DC the current cannot travels long distance safely, cannot travels long distance safely in case of DC, but in AC the current travels long distance safely. Another major difference between AC and DC, that AC in DC power factor, in power factor is always 1, PF is always 1 in case of DC, but in case of AC the power factor varies from 0 to 1 in alternating current. But in a DC there is only resistance circuit, you will found there is only resistance, but in case of AC there is a resistance, inductance and capacitance. So, 3 parameters, one is your resistance, inductance and capacitance. In case of AC alternating current there is your resistor, inductor L and capacitor. It is only you will found there is only resistor in case of DC, but this module covers of only DC networks. That means only resistance, voltage and current. So, first of the module starts from Ohm's law. What is Ohm's law? Ohm's law. A great German scientist, they developed a uniform formula which will help us to find out the voltage, current and resistance. To find the values of voltage, current and resistance, and 3 parameters. One is the resistor value, voltage value and current value. So, if there is a conductor, the potential difference between any conductor is directly proportional to the current flow through it. The potential difference, Ohm's law states that potential difference, it states that the potential difference between any conductor is directly proportional to the current flow through it. So, if any conductor, so voltage mathematically voltage is directly proportional to the current flow through it. V is proportional to I, or V equal to, if there is a proportionality constant, there is a resistance, V equal to I into R. So, voltage V equal to current into resistance. So, Ohm's law states that potential difference between any conductor is directly proportional to the current flow through it, or V is directly proportional to the I and V equal to IR, I is the resistance or proportionality constant, that is your resistance. So, V equal to I into R, if the current is given and resistance given, you can find out the voltage V equal to I into R. If voltage given, current given, you can find out the resistance. If any one of the parameter value is absent, another 2 is present, you can find out the other 2 values. So, Ohm's law is a formula, is an empirical formula, V equal to I into R. You can find out voltage, current or resistance. V equal to I into R, or we may say I equal to V by R to find out the current if the voltage and resistance is given, or R equal to also R equal to V by I. So, voltage, current and resistance you can find out in case of Ohm's law. So, there is an analogy how to the Ohm's law, that is your voltage is directly proportional to the current. What is voltage, what is current and what is resistance? Suppose if I will tell you what does it mean voltage, if we analyze with suppose a water tank, if a water tank suppose there is a water tank or water tank situated is installed at the top of the floor. If it is analyzed with your water tank at the top of the floor, here also here the flow of water, the direction is like this. let this is your water. Okay. So, this is your a tank, water tank. It is analogous with a water tank. We can say that how to relate, that is your voltage, current and resistance. If it analogous with your water tank, suppose it is installed at your top of the floor. So, this is nothing but a water, full of water. We can say that this is a water is nothing but your charge, and here this is your hose at the end of the this is a pipe, the water is flow through this pipe, and at the pressure, water pressure, we can say that this is your voltage. Okay. So, voltage is nothing but your water pressure at hose. This is nothing but your voltage. Do you understand or not? And this is your charge, and this is nothing but your the flow of water. Flow of water, we can say that this is your charge or current. This is your current, and this is nothing but your I. And if there is some restrictions are there, this is your water and there is a pipe, and I am restricted like this. That means the pressure at bottom end of the hose will be maximum or not. This is the rate of the flow of water. The flow of water, I can say that is your current I, and if you restrict the water, we can say that this is nothing but your resistance. Restrictor is nothing but your resistance. That means in a Ohm's, in a German scientist which gave an empirical formula which is find out the voltage, current and resistance. Without using this formula, we can't evaluate the voltage, current and resistance. If there is a DC networks or any complicated networks, you have been asked to find out the voltage and current through a particular branch, then you cannot find out without help of the Ohm's law. So, without help of the Ohm's law, we cannot find out the voltage, current and resistance. So, this is nothing but our Ohm's law. Next, that is your Kirchhoff's law. Kirchhoff's law. What do you mean by Kirchhoff's law? Already you have studied in 11th, 12th. The generalization of Ohm's law is Kirchhoff's law. Ohm's law means what? Ohm's law, we can find out the voltage, current. If the current given and resistance given, you can find out the voltage. If the voltage and resistance is given, you can find out the current. So, if there is some complicated networks, you have been asked to find out the voltage or current through a particular branch, then using with the help of Kirchhoff's law, we can evaluate the voltage or current to determine the voltage or current for a particular branch. So, what is Kirchhoff's law? Kirchhoff's law, we can say that it has two laws. One is your Kirchhoff's voltage law, another one is your Kirchhoff's current law. It has two laws. One is Kirchhoff's voltage law and another one is your Kirchhoff's current law. Kirchhoff's voltage law, we can say that in KVL, Kirchhoff's voltage law, and Kirchhoff's current law, that is your KCL, that is your Kirchhoff's current law. So, Kirchhoff's voltage law and in Kirchhoff's current law, we can say that Kirchhoff's junction law or Kirchhoff's point law. Now, let us go through Kirchhoff's voltage law, KVL, Kirchhoff's voltage law. What is KVL? Algebraic sum of the potential or EMF is equal to 0. Sum of the potential, algebraic sum of the potential in a closed electrical loop, or algebraic sum of the potential or EMF in a mesh is 0. algebraic sum of the potential in a closed electrical circuit is 0. Algebraic sum of, it states that algebraic sum of potential, algebraic sum of the potentials or EMFs, algebraic sum of the potentials in a closed loop or mesh is 0. So, Kirchhoff's law is the generalization of Ohm's law is Kirchhoff's law. Algebraic sum of the potential in a closed loop or mesh is 0. That means, when we are going to apply the Kirchhoff's voltage law, the loop must, that means there is a closed loop. Okay. If there is a closed loop, then you can apply the Kirchhoff's voltage law. So, let us take an example. Let us take an example. A simple electric circuit suppose this is your, let there are two potential source, that is this is your, let 10 volt, this is your 5 volt, this is your 4 ohm, your 2 ohm and this is your 2 ohm. If the question asks, find out the current through each branch, find the current flow through each branch of the electrical circuit. You might have studied already in class 12th. When you are going to apply Kirchhoff's voltage law, the sign convention is very much important. Sign convention means what? So, that means if there is a resistance, R, if the current flow through here, that means entering end and this is your leaving end. Entering end is positive and leaving end is negative. We are going to calculate the potential. If there is a resistance, how much current flow through it, and then multiplied it, that means you will find the voltage or V. Algebraic sum of the EMF or sum of the potential in a closed loop 0. Suppose this is a closed loop. How many number of loops in this network? There are two networks or two loops, one loop and another loop, first loop and second loop. In first loop, you will find one is your one voltage source and two resistance. If there is a resistance, you must apply the current, because voltage equal to current into resistance. So, that means here one potential, here already there 10 volt, there another one resistance, you just multiplied current, how much current flow through it we will discuss. Then here also resistance, then the multiplied with current. One voltage source, this. In first loop you will find three terms, one voltage and two resistance, means two drops. Total EMF is how much? 1, 2 and 3. Similarly, in second loop or second mesh, there is a potential and there are two resistance, there is a potential drop here and there is a potential drop here. You will find 3 EMFs, one voltage, another voltage, another voltage. So, algebraic sum of the potential means how many you will, if you apply KVL in this second loop, you will find the 3 EMF or 3 potential, here also 3 potential. Do you understand or not? Before applying KVL in this example, you just know the sign convention. What does it mean? When, if you go from plus to minus or energy conversion, in KVL the energy conversion means when you go from higher potential to lower potential, there is your energy voltage drop, and if you go from the lower end to higher end, there is your potential rise. There is your potential rise and potential drop. So, if there is a resistance, if you go from plus to minus, you will take an account the minus, that will be minus. Remember, suppose if we set R and there is a potential V, suppose current flow through the resistance is I. So, V like this, the V, this is your plus to minus minus, that is your minus IR, minus IR. The potential or EMF that we can calculate here minus IR. If you go from the plus to minus, that will be minus. If you go from minus to plus, that will be plus. This is very important. Sign convention is very important. If you slightly mistake the sign convention, then your entire calculation will be wrong. If you go from plus to minus, you will take into account minus. If you go from minus to plus, that will be plus. Look at this example here. First, I am just naming here, that is your A, B, C, D, E and F here. So, first of all, then like this is your plus terminal, this is your minus terminal. I am assuming here the current, this is your two loops here, I1, let the current is I1. Look, one important thing is, when you are assuming the clockwise direction of the current, then all the loops you have to assume in all the loops the current flowing in the clockwise. If you assuming the current will be anticlockwise, all the loop in anticlockwise. Do you understand or not? So, first of all, you assuming the current flow through this loop is clockwise here also, and here also this is your clockwise. So, let the current flow through this is your I1 and this is your, let the current is your I2, then what will be the current flow through this branch? This is your I1 and this is your I2. This will be how much? I1 minus I2. If the 10 ampere current flow through this resistance, this is your 4 ampere, then how much? This is your 10 minus 4, that is your 6. If this is your I1 and this is your I2, and this will become how much? I1 minus I2. This is your I1 minus I2. Remember? Are you getting or not? First of all, you identify how much current flow through the each resistance, then you will apply the Kirchhoff's voltage law. Plus to minus minus, minus to plus plus. Here the current, here the terminal here plus and this will be minus. The current here entering plus, leaving minus. Here a current entering plus, leaving minus. So, that means in first loop there are two resistance, sign convention you know, there is your plus to minus. If you move from plus to A to B, there will be minus current into resistance, the potential you can calculate here. And if you flow from B to E, plus to minus minus current into this resistance. If you flow from B to C, plus to minus minus I2 into this resistance. If you considering here, minus to plus is plus. If you here, plus to minus is minus. Are you getting or not? So, that means when you are going to calculate Kirchhoff's voltage, apply KVL. So, this is an condition first is the loop must be, there will be a closed loop or mesh, then you can apply the KVL. So, let us consider the first loop. Considering the loop or mesh, considering the loop A, B, E, F, A, B, E, F, A, apply KVL, apply Kirchhoff's voltage law. If I will consider the loop A, B, E, F, A, already I told you plus to minus minus, minus to plus plus. I am going from here A to B, there will be current will be plus to minus, that will be minus. Current is I1, resistor is 4. What will be potential? What will be voltage? That is 4 into I1. So, that will be minus 4 I1. Are you getting or not? If I am going from A to B, that will be plus to minus minus. Direction is very important, sign convention is most important. Minus I1 into resistance value 4 into I1, A to B, then B to E. If I am going from B to E, here plus, here minus, plus to minus minus, current is how much? I1 minus I2, resistance value is how much? 2. So, that is minus, current value is how much? I1 minus I2 into resistance value is 2, that is your 2 into this, A to B, B to E over, then E to F, there is no resistance value or voltage, only then F to A. I am going here minus to plus is plus. Already I told you plus to minus minus, minus to plus plus. If F to A minus plus plus, plus 10 equal to 0. This will be very very important. When you are going to apply KVL, then sign convention is must, plus to minus minus, minus to plus plus. If there is a resistance, multiply with the current. If there is a voltage, keep as it is. So that is the equation is A to B plus to minus minus, then 4 into I1, that is your EMF, then or voltage, then B to A plus to minus minus, then resistance 2, current I1 minus I2, then E to F, there is no resistance or voltage source, then F to A minus to plus plus, plus 10 equal to 0. If you, I will simplify this, minus 4 I1 minus 2 I1 plus 2 I2 plus 10 equal to 0. Minus 4 I1 minus 2 I1 minus 6 I1 plus 2 I2 equal to minus 10, or 6 I1 minus 2 I2 equal to 10. This is your equation 1. Are you getting or not? So, if you apply KVL in the first loop, you will get this equation, algebraic sum of the potential in a closed loop 0. If there is a resistance, multiply with current, going from plus to minus is minus, minus to plus is plus. The equation, the first equation is 6 I1 minus 2 I2 equal to 10. This is your first loop. Then apply KVL in the second loop, considering the loop, considering the loop that is your B, C, D, E, B, B, C, D, E, B. Apply KVL, apply Kirchhoff's voltage law. B to C, again plus to minus minus, current is how much? I2 and the resistance is 2 I2, plus to minus minus, minus 2 I2. Then here there is a source potential or battery, plus to minus minus. If there is a voltage, keep as it is, that is your minus 5. D to E, there is no resistance or source. Then E to B, remember here I am going E to B, there is a minus and there is a plus. If I am going from minus to plus, that will be plus. So, minus to plus is plus, that is your current is how much? I1 minus I2, I1 minus I2 into resistance value is 2. Just simplify it, minus 2 I2 minus 5 plus 2 I1 minus 2 I2 equal to 0. Remember this is equal to 0, or 2 I1 here minus 2 I2 minus 2 I2 minus 4 I2 minus 5 becomes right hand to go to right hand side, it will plus, that is your 5. This is the second equation. So, 2 I1 minus 4 I2 equal to 5. If I will solve this equation, suppose this is your equation 1 and let this is your equation 2. If I will solve this two equation 1 and 2, I can find out 1 and 2. So, 6 I1 minus 2 I2, 6 I1 minus 2 I2 equal to 6 I1 minus 2 I2 equal to 10, equal to 10, equal to 10. Another one is your 2 I1 minus 4 I2 equal to 5, 2 I1 minus 4 I2 equal to 5. This is your equation 1 and this is your equation 2. So, solve equation I1 and I2, you will get the value of I1 and I2. If you will solve this, how will you solve this? Simply you multiply equation 2, 3, that is your 6 I1 minus 2 I2 equal to 10. If you multiply equation 2, 3, that is your 6 I1 minus 12 I2 equal to 15. This is your minus plus minus. Minus 2 plus 12, that will be how much? 10 I2 equal to minus 5. I2 equal to minus 5 by 10, that will be minus 1 by 2. So, I2 value is nothing but is your minus 1 by 2. Substituting the value of I2 in any one of the equation, that is your 6 I1 minus 2 I2, 2 into minus 1 by 2 equal to 10, 6 I1 plus 1 equal to 10. So, 6 I1 equal to 9. So, I1 equal to 9 by 6, 3 3 is 9, 3 2 is 6, that is your 3 by 2. The value of I1 here, that is your 3 by 2. So, in this two loop you will get the two equations. Solving these two equations, we can find we got the values I1 equal to 3 by 2, I2 equal to minus 1 by 2. Next what we will do? Then we will calculate the what amount of current through the each branch of the circuit. So, here the branch AB, if we will consider how much current flow through the each branch of the circuit, branch of the networks, I1 already I got I1 first just make a table. Branches voltage, write down the branches AB, the current flow through the I1, that is your what? 4 I1, the value is how much? 4 into I1. Then BC is nothing but I2, the value of I2, BC, that is your current flow through the BC is I2, that is your I2 into R2, I2 into 2. Similarly, BC, AB, BC, then BE, branch BE, the current is how much? I1 minus I2 into 2, I1 minus I2 into 2. So, we got I1 is how much? I1 is 3 by 2 minus 1 by 2, I1 3 by 2, I1 is 3 by 2 and I2 but minus 1 by 2. So, I1 value is 3 by 2, 4 I1, AB 4 I1 equal to 4 into I1, 3 by 2, the value will be how much? 6 volt. So, branches at the AB, the drop is 4 volt and the current I1 is how much? 3 by 2. 3 by 2 is 1.5 ampere current flow through this branch and the potential drop across this branch AB equal to 6 volt. Similarly, BC, I2 into 2, I2 is minus 1 by 2, 0.5, so minus 1 by 2 into 2, that will be your minus 1 volt. So, in the branch BC, the potential drop or voltage is minus 1 volt and current flow through the BC is I2, that is your minus 1 by 2 ampere or minus 0.5 ampere. Similarly, branch B, I1 minus I2, I1 is 3 by 2, that is your 3 by 2 minus 1 by 2, I1 minus I2 into 2, that will be how much? 3 minus 1, 2 by 2 1, 1 into 2 volt, this is your 2 volt. So, in B, here the drop is 2 volt and here AB the drop is 6 volt and BC there is your minus 1 volt. So, this is a simple example of how to apply KVL in an closed electrical circuit. Thank you.